Springtime thunderstorms usually travel faster with the steering wind. These storms can move at 40 to 50 miles per hour and as fast as 60 miles per hour. From fast storms like these, it's not hard to get damaging wind. All it takes is a medium wind gust added to the forward storm speed to create winds approaching 100 miles per hour. Any thunderstorm can create gusting winds, but sometimes those bursts of wind are extreme. When air rushes out all at once from beneath a thunderstorm, it is called a downburst. These happen typically when dry air enters a thunderstorm and then rain falls into the dry air. The rain evaporates, cooling and causing the air to become dense and heavy. The air falls to the ground and spreads out in a straight line. This burst of wind is called a straight line wind. Straight line wind can have the same sound, power, and damaging impact of a tornado. If the downburst occurs only in a small area, then it is called a microburst. A downburst, especially in arid climates like deserts, is responsible for dust storms or sandstorms. The wind travels away from the thunderstorms, carrying sand and dust, and sometimes creates a wall. The particles reduce visibility and leave a coating on everything that they fall on. The most intense dust storms can arrive as a brown wall before they choke out daylight. Dust storms may also result from regular, steady, or gusty wind over dry land. All high wind gusts and downbursts are a huge hazard to aviation due to sudden wind shear. This is most dangerous for aircraft during takeoff and landing. When thunderstorms produce a continuous series of powerful straight-line wind bursts over the course of tens of minutes or several hours, that is called a derecho. Derecho is a word with Spanish origins that means straight ahead. This type of windstorm can do damage similar to that of a family of tornadoes. Ordinary or severe thunderstorms that move as a line create what is called a squall line. Squall lines have larger areas of impact than individual thunderstorms. Thunderstorms that merge, interact, and feed each other while moving as a group that persists for many hours produce a region of low pressure called a mesoscale convective complex. These are common in the plains of the central United States at night in the warm season. They supply rainfall for agriculture, but at the potential expense of wind and hail damage. Individual thunderstorms can become so intense that they generate their own environment. The largest of them rotate slowly and maintain a strong updraft. These are called supercells. They are in such perfect balance that they can last longer than typical thunderstorms as they produce intense and severe weather. Supercells can create tornadoes. Most thunderstorms do not become supercell thunderstorms, and most supercell thunderstorms do not produce tornadoes. Any thunderstorm with potential for great harm is watched carefully on satellite and radar by humans. There is an organization of volunteer weather spotters in the United States called Skywarn. Their mission is to observe threatening weather and relay reports back to the National Weather Service to help improve forecasts and warnings. When you are outdoors or traveling, keep updated to warnings for severe storms with a NOAA weather radio or a smartphone. In a thunderstorm process that's not fully understood, it takes a perfect mix of rising air, wind shear, and rotating air to create tornadoes. Tornadoes may come out of the rear of a supercell thunderstorm from a low-hanging cloud feature called a wall cloud. To make storm tracking even more difficult, not all wall clouds produce tornadoes. The one certainty of thunderstorms is they all produce the hazard of lightning and the sound of thunder, even if you can't hear it.